start things correctly, or if I'm going to fall to the SBAG20 trap. Okay, boy, having this camera here and knowing that. All right. Hi, everyone. So I'm going to talk about the science section, and not only are we going to be doing, kind of the cutting edge small bodies science, but cutting edge Twitter memes. So for those of you that are on Twitter, I made this last night because I just had to do it because that was the Twitter meme. It'll be posted to the SBAG website. You don't have to look at it too much right now. But this is following I think it's Unscience and Animal. This is Unscience and Asteroid. So why do we have goals? Tim talked about this, so we'll try not to dwell too much. But this started 4 or 5 years ago at SBAG12, and some presentations that are still online that Nancy Chabot, who was the chair at the time, posted. And as Tim noted, these are valuable resources for NASA. Other assessment groups have had good luck with their similar documents. And then the guiding principles are that, we want to have this document be sustainable and easily updated, and that it should actually be useful. There was no real precursor document to this, but the closest thing to a precursor document had hundreds of pages, and the thought was that was just not going to do anything more than take up disk space. So we're trying to keep this, reasonably short and to the point. And so then following that, the science objectives for small bodies, the approach, I'm trying not to say the word goal. The approach is to not just talk about missions, but talk about, again, the breadth of work that is done by the community. So ground-based observations, sample work, theoretical work. Again, as Tim mentioned, not to prioritize among targets because we have so many of them, and also to leave things very high level, and to solicit contributions from the community at large. So, as Lindley said, the small bodies community is been very successful lately, budget-wise, and also we've had a lot of missions going to and intended to go to bodies that fall within our purview. So we want to continue to motivate that exploration. We don't want to say, okay, well now, we've had enough small bodies stuff. We're good. There's a lot more to do because the population is so diverse and we do so many things. So the next couple of slides just kind of vaguely motivate that. And I put these together for a variety of reasons. This just kind of tries to show where we're at and where we're not yet at. The x-axis there is mass on a log scale. The y-axis is maybe more notional, but kind of shows in a grand tack like. Shows in more of a grand tack sort of history. Kind of notional formation locations from the inner solar system to kind of in and among the Jupiter-Saturn region to the ice giants and beyond. Within each of those sections, the y-axis placement is a little more to just kind of separate things out so you can see them. And these are the bodies that are, the small bodies that are reasonably well visited by spacecraft with no disrespect intended to Galileo for going to Gaspar and Ida, say. And you can see that we have objects in the small bodies that cover kind of, 10 orders of magnitude in mass, and even smaller if you think you want to know about the Chelyabinsk impactor, while everything from Mercury to Neptune is kind of crammed in here in a much smaller mass range. This line kind of roughly separates the intact planetesimals from fragments of larger bodies. This is the sort of thing that Bryce talked about on the first day. And there's a wide range of this phase space that is just not well explored, whether for inner solar system objects or outer solar system objects. Whoops. I guess I'll back up slightly. So this empty space is only interesting to the extent that it tells you anything. If there's nothing to be learned from exploring that empty space, then that's not so interesting. But of course, there is interesting stuff. We can look at that top row there, which are just a bunch of balls of mostly hydrogen, and who cares? They're just mostly balls of mostly hydrogen. They got to be the same, right? But over the 5 order of magnitude mass range from Neptune to Betelgeuse, there's a lot going on. And again, I'm sure I don't need to tell people here this, but the ones on the left have weather, the ones on the right explode. So that's a lot going on. On the bottom here, the 10 orders of magnitude between Itokawa and Vesta, and I could have done this with comets or KBOs or whatever. Our friends in some of the other ags might go, look, they're balls of rock. What could be going on? But the processes that act on these bodies and that move them around and the internal processes that they had vary greatly from something like Vesta to something like Itokawa, let alone then something smaller like, again, the Chelyabinsk impactor or something. So we have a lot to motivate us to learn more and to go to more of these objects that have formed in different parts of the solar system. So maybe this should have been the last slide. The current status, we had a document in 2016 that was the previous rev of this that went through community input, and so has been reasonably well vetted. There's a document that Lindley has presented here a few times that I think is the common themes in planetary small bodies research. I think is the title of it. It's 2 or 3 pages, and it shows how they describe small bodies missions to people at NASA. We have reorganized this document to better fit the themes in that document to make it easier to kind of translate back and forth. So that gives us 4 objectives, still kind of tweaking the wording of these 4 high-level objectives, if only for parallel grammatical structure. Basically, it's understand the formation of the solar system, refine our understanding of the evolution of the solar system, understand the delivery throughout the solar system of elements that initiate and sustain life, and then understand processes in an active solar system. So these are the top level things. So in this in this round of discussions, the document has gone out for one round of community commentary. We have about a dozen people that signed up to look at this, and I've incorporated their comments. We've then sent this around the steering committee, and I've got most of those comments solicited, and then we're going to send it back out. Of course, everyone is welcome to join in and comment on the draft that goes out, not just the dozen people that signed up, a year ago. So we'll have that information going out when the document does. To go into a little more detail of the sort of sub-objectives of the 4 main objectives, I don't know that I necessarily want to read through all these, but I guess that's what I'm going to do. For understand the formation of the solar system, to kind of try to quickly summarize, it's find and characterize new samples by whatever means you can. Study the composition of small bodies, again, kind of however you can to constrain their origins. Determine the timing of events in the solar system, whether using samples or using remote techniques, crater counting, et cetera. And use the distribution of these compositions and ages to make predictions about how planetary systems form that can then be used to look at other solar systems or other exoplanetary systems, I guess. Number 2, refine our understanding of the evolution of the solar system. Number 1 there is, of course, continuing and improving research programs for all of the small bodies. Understanding how small body orbits change through Yarkovsky effect, through planetary encounters, et cetera. I suppose technically you can have something like non-gravitational effects for comets in there as well, although that might also fall somewhere else. Determine how the current distribution of small bodies evolved, try to determine whether there's some connection between evolution and composition, look at the most recent dynamical history of objects, and then again, apply what you've learned about our solar system from small bodies to other exoplanetary systems. This is kind of the AstroBio E1. Understand how prebiotic materials basically were delivered by small bodies throughout the solar system. So there's measuring volatiles on small bodies, comparing the volatiles between objects to understand the distribution of volatiles early on, a look at individual bodies to learn how volatile transport and other things affect the distribution of volatiles on single objects, determine how much of these volatiles can be delivered throughout the solar system, and then look for biological potential on small bodies, which I guess I never would have believed when I was in grad school, but there is definitely a case to be made that some SBAG bodies could have some astrobiological potential for sure. And then understand the processes in an active solar system. Understand the structure of small body surfaces and how properties are modified by being in space. Understand the overall physical properties of small bodies as a population. Look at the evolution of the interiors of small bodies, including differentiation and melting, et cetera. Determine basically magnetic fields, past or present on small bodies, and then look at processes that lead to mass loss from small bodies. And this would be whether, again, cometary or through disruption, et cetera. There are some things, oh, that's right. Then we also have the objectives are at a high level process, looking at the community of the population of objects as a whole. But we do have short supplement sections about different object types. The first 6 of these were in the previous document. They've been updated to reflect what we've learned about those objects and missions that have completed, missions that have been selected since the last time. We've added number 7, and I don't know if interstellar visitors is what the community is going to end up calling them. It's sort of what we've been calling them. I still like exo asteroids with say that's a diacritical over the A to make sure, it's like you're in the New Yorker. But I don't like Xeno, because Xeno would be, I'm sorry, I don't like exo, it's Xeno. Xeno is what I like, because exo asteroids would be asteroids in other systems, and a Xeno asteroid is something that's come from outside. So anyway, that's what we're calling group number 7 for now. Of course, that's just, right now, just a population of 1, but hopefully there'll be more. Okay, the question is whether it's worth differentiating the short period from long period comets. I don't know. I guess I would have to look at the one page in particular. I guess the reason to differentiate them would be because the science is different for them, and is that would that be because oh, I don't want to put words in your mouth. I can imagine why someone would want to do that, but I don't know that I've heard someone propose to do it. Okay, and then to follow that, there's also another suggestion as to whether it's worth separating near-Earth asteroids from main belt asteroids.
Well, I mean, you could take that in a lot of ways. You could say rebel piles versus dwarf planets. Yeah, I mean, you have to stop the division at some point, and maybe underneath each one of these, you have specific questions to those subgroups. But maybe that's one way. Sure. Yeah, the comment was that obviously there's only, it's the classic lumpers versus splitters argument, and so whether it's more appropriate instead of making those sorts of splits to include specific questions about different subgroups on the one page, and I think, well,
these are one-page things, and they're pretty broad. I don't know that we necessarily break them down that much, but that would be an approach. I saw a couple, yeah, Hannah.
Two comments on mine, just with the comments, their source regions are potentially different, and then a comment about the interstellars, they could be comments too, so maybe your name, that's my comment, your name, is potentially better.
Okay, so two comments for the people online who aren't hearing Hannah, perhaps. There was the motivation that because the source regions for short and long period comments could be different, that might be a motivation to separate them. And then a suggestion that the name, is it the name interstellar visitors they don't like, or the Xeno?
I think the Xeno asteroids.
Yeah, well, you could have Xeno asteroids and Xeno comets. Xeno small bodies. Xeno comets are just comets?
Xeno objects.
Xeno objects. Oh, yeah, and then you can still have keep the diacritical. That's important to me. Yeah, Meg.
We had a debate in the LS people science operation because we broke down into populations, and I got a lot of pushback on comets, because then the main belt asteroid people went, well, there's a main belt comet, and then there's also active asteroids that are more collisional. So then how does that fit into comets? Because when you think of comets, you think of long period, short period. So they went with active objects, and so we left it at that and lumped them all together and said it's activity, and then all the kind of things the science would be doing would be teasing out sources, et cetera. So I don't know if that's a good suggestion to take comet and make it active object, and then you lump in comet, short period, long period, and so, main belt comments in there too.
Okay, so Meg notes that the LSST science collaboration took the avenue of defining things as active or inactive objects, and that that gets around some of the things we're talking about here. This is another classic problem, right? Because from the observational point of view, you don't want to know if it's fuzzy or not, and then let other people sort out the details. From our point of view, an active object that's a member of the Themis family, or that is active because it's a rocky body that spun itself up and is now disintegrating, is going to have a different set of relationships to the objects around it. And I personally, I guess I need to think about it some more. My gut feeling is that sort of thing would be, we're using asteroids and comets as signifiers of origin and not signifiers of currently what's going on, but it's
taken under advisement.
Yeah, I will thank you, Tim. We will take it under advisement. And of course, as a member of the community, Meg, you are of course also welcome to continue to be involved in this. Anything else out there? I've got one more slide, I think. So there were some community comments that have not been addressed or included in the current version, which does not mean they won't be, it just means they haven't been. A question about plasma interactions with surfaces and exospheres. I think my current understanding of the Dawn results is that, for instance, people think that Ceres has a temporary exosphere based on what's going on with the sun at the time. I'm looking at Julie, and I'm hoping she's going to nod or shake her head. Yeah. Okay, she hedged. That's fine. But it's certainly that this plasma interactions with surfaces also would involve things like levitation, dust levitation, electrostatic levitation. And at least it has been proposed by some that plasma interactions with the surface of Ceres has led to an exosphere, a temporary that varies with solar activity. This again may, whether it ends up as a couple of sentences in one of the goals or not, and where exactly it would go. I guess it would go in the active object, not active in the sense that we were just talking about, but in this objective, I could imagine it going somewhere in understand the processes in an active solar system.
We looked at the condition
Oh, sure, but, okay, so Julie is saying that there's no dust on Ceres, but I thought the Herschel results were being explained by the ice sublimation, seeing ice or not, seeing water or not seeing water.
We are reviewing, we are reanalyzing the Herschel solution. We want to look at things. There are two orders of magnitude.
Okay, so it sounds like, again, for the people online, that is an ongoing research. Second bullet, theme 3, the astrobio one, it talks about volatiles a lot. It doesn't really talk about non-volatile prebiotic materials. I am not enough of an expert to know what specifically that may mean. I think in principle that would be the place for them. I mean, if they are elements that initiate and sustain life, then that's where they would go, whether or not they're volatile per se. So maybe that's just as simple as yeah, maybe that's a matter of changing the wording in one of these just to explicitly include non-volatiles or something. Add phosphorus to the list. Okay. Yes, Bryce.
So this is kind of going in the exo-comets direction, but is there any interest to study small bodies around other stars, like variability of debris disk, excluded white dwarfs?
Is there interest, so Bryce asked if there's interest in studying small bodies around other stars, like debris disks and polluted white dwarfs, et cetera. We, I think at one point talked a little bit, or were thinking about explicitly including sort of connections to exopag and the like, and we definitely had comments about taking about that sort of thing, about how there's this connection that can be made. I honestly don't remember to what extent we included that in the current draft or not, but I think we're that's an obvious thing to try, since there is that, you know, we have other you know, in at least objectives 1 and 2, the last bullets there about understanding the pathways of dynamical evolution in other planetary systems and testable predictions about forming planetary systems. Those are kind of have an exoplanetary bent. And then the final 2, there was a suggestion to include not only objects, supplements about objects, but about key facilities and programs, and about data archiving, data mining, or perhaps using that latter one as an appendix. I think the content we are likely to try to put in somewhere. The supplement sections about objects do have subheadings, including things like what are the key facilities. So that might be just where we'd have to point to. And I think data archiving and data mining also, if we could have I could imagine an appendix, but it was, but such an appendix would again have to be kind of short and to the point. I can imagine, you know, big data meaning big appendix. So I think we can, you know, hopefully again include this content in some way that's not adding significantly to the length of the body of the paper. So that's my last slide. If there are any other questions, yes, Tracy.
So one thing that I've been noticing in a lot of these kinds of talks, it kind of goes in your theme 4, but the idea of really calling out specifically wanting to do lab data and like actually calling out that we need more lab measurements of all of these things so we can do the comparison with the theoretical models and then with actual operational. And then I'll go ahead and ask it explicitly for the UV, but also just base weathering type experimental lab programs so that NASA's more aware that we really do need to get more lab data.
Okay. Tracy says that That might be a Velvet Underground song, Tracy says. Tracy suggests that we also pay attention to laboratory measurements and laboratory facilities and the importance of making those to call those out explicitly, not just talk about theory and, telescopic observations. And so that point is well taken. And if it is not already in there explicitly, we can certainly do that. I'm sorry. Yeah, hang on a second, Rick. Are you thinking well, we could also put them in at this level? Is that specifically what you're saying, or just to make sure, to say not only combine theoretical models with measurable properties, but to include it at the top level, or just make sure that there are sentences in there?
Very good. But just
Okay.
explicitly called out.
Okay. Rick?
Planetary defense, science, they need to point at each other. It's all science, but learning about the objects informs planetary defense, and planetary defense informs science. Somehow, things can be pointed at each other.
There is also an introduction that includes some pointers to things that are common to multiple goals. So the way we structured it the first time, and what I would like to continue to structure it, is that the goals are just the goals for this, that, and the other thing, and then we make the connection
You have a feed.
in an executive summary. Yeah, and it's also important, as an asteroid, happy member of Team Asteroid, but to know that I'm also a member of Team Small Bodies, and planetary defense is very specific to a very small subset of small bodies. And, this particular document, while it of course will point to other places and other places will point to it, people who study KBOs are not going to be so involved in planetary defense. People that are concerned about the Trojan asteroids, people who are concerned about dust, IDPs, maybe they would be more concerned about NEOs, but not so much. So this has to be a broad document that answers that people who are doing science across the board are gonna draw from.
And what the rationale behind the goals is different from planetary defense. Yeah, and I guess the thing I'd say is we represent the people interested in exploration of small bodies. That includes scientists, that includes people whose prime motivation is planetary defense, that includes people whose prime motivation is commercial, that includes people whose prime motivation is human exploration. There are some things that are common to all of those, the most obvious one being the discovering more nearest objects, but there are things that are very different, and I personally would rather see each of these sections say what the goals of the part of the community that does this, what are their goals? But there do need to be things that look and see, this is common to multiple goals.
That answers my question. You do have a place for the different aspects that corroborate each other, pointing to each other.
Julie?
I like the chart you presented at the beginning with the project.
This one or the one before it?
Well, that's great.
Yeah, so it would be good to add the part of the results from the casting mission, because casting of the TV analyze maturity.
Oh, no, yeah, sure. Well, I've got Titan, but it's, sure, I mean, Phoebe is going to be, probably like here-ish or something, I'm guessing.
Very questionable. And also the reason, because there is a lot of interest right now about accretion and back to
Sure, thanks. Yeah, this was, just made as a schematic to show there's a lot more to be done. It's not, it was meant to kind of show the small bodies that were reasonably well studied and include, here's Psyche and here's the Lucy targets. We could, if we could cram as much in it as right side as we want, in a sense. So it's not, it's meant to be just kind of a notional idea of what more there is to do, not a, here's
It's not exhaustive.
But it's a very good.
not a,
It's a very good chart, and if it's published on our website, people have it. So if it could be accomplished, people have it.
okay, thanks.
Okay. All right, thank you, Andy.